Yo, 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 it's your man Jimmy Chan. So today we're talking about rational functions and their graphs. So I think the best way to do this is to show you how to graph rational functions. So because within those steps, there are some things that you need to review, and there are some things that are new that will help you graph a rational function. So we're going to graph the function f of x is equal to x minus 2 over x squared minus 4. All right. So the first thing we need to do is to determine symmetry. Okay. So that's going to be the first thing we need. Right. So back when we determined symmetry, we had a couple of things, right? We were given f of x, and the next thing we did was we found negative f of x, right? And with that being said, then we went back in and we found f of negative x. And if the result of that was going to be similar to f of x, then we knew a couple of things. One, we knew that it was going to be even function. And we also knew that this had symmetry about the y-axis. However, if the f of negative x came out looking more like negative f of x, then we knew it was going to be an odd function. And with the odd function, we knew that it has symmetry about the origin. Okay, so let's check it out. All right, so our f of x is equal to x minus 2 over x squared minus 4. Okay, so that means we need negative f of x. Well, that's going to equal to negative x plus 2 over x squared minus 4. Now, your first question is going to be, why did you distribute the negative through the top and not the bottom? Well, here's the reason. So if I was to negate 1/2, okay, this means two things. It can either mean that it's negative 1 over 2 or 1 over negative 2. It's either going to go through the top or go through the bottom, but not both. If it went through both, then I come back with a positive 1/2, and that is not the same as negative 1/2, obviously. Okay, so that is the first reason. Okay, so if you were to put it through the bottom and you say, hey, this is equal to x minus 2 over negative x squared plus 4, that'd be okay too. I'd be all right with that. Okay, that does make sense as well because you put the negative through the bottom. But it definitely doesn't go through both, because if it goes through both, then you have the original back again. Okay, so that's the reason why. All right, so let's now find f of negative x. Well, that would be negative x minus 2 over negative x squared minus 4. So that's going to equal to a negative x minus 2 over an x squared minus 4. Okay? With that being said, my question is now, does it equal to f of x? And the answer is no. Okay. Does it equal to negative f of x? And the answer again is no. So with that being said, that means I have I know that there is no symmetry about the y-axis nor the origin. Okay? So that is taken care of. So there's no symmetry. All right. So we move on. Now we're going to the second step. Okay. Now let's move on to the second step. The second step is for me to find the y-intercept. Well, what do I know about the y-intercept? That's right. X is equal to 0. So in other words, I need to find f of 0. Okay. So let's go ahead and find f of 0. Well, that's equal to 0 minus 2 over 0 squared minus 4. Okay. And what does that equal to? We have a negative 2 over a negative 4. So we have a 1/2. Cool part about all of that is that I have a point, which is the so-called y-intercept. So I have the point 0, comma 1/2. Okay? So that's going to be kind of important. There we go. All right. So now we get into the third step. The third step is to find the x-intercept. Okay, and what do I know about the x-intercept? Let's choose a different color, like orange. What do we know about the x-intercept? That's right, y is equal to 0. What does that mean? That means that f of x is equal to 0, right? Because it means the same thing. F of x and y is just a function notation. Okay, so let's go ahead and do that. So I'm saying that it is 0 is equal to x minus 2 over x squared minus 4. Okay? Now, you're going, well, how do I solve this? Right? Well, here's the good news. I believe that if I had a 0 over anything, 0 divided by anything is what? 0. However, if I had anything divided by 0, then that would be undefined. Right? So what does that tell me? That tells me that if I just take the numerator and set it equal to 0, I'll know what would make this fraction 0, or this rational 0. Okay? So all I have to do is take the x minus 2 and set it equal to 0. So what do I get? I get x equals 2. Okay, great. What does that tell me? That tells me I have a point as well. And the point is going to be 2, 0, because my y value is 0. All right, cool. So I got another point. All right, now I got 2 points there. All right. Now let's get to the fourth step. Yeah, I never think about that. There we go. What do we got to do for the fourth step? Well, we need to find the vertical asymptotes. This sounds like something new, right? Well, the vertical asymptote is actually related to your restrictions / your domains. Okay. So, a vertical asymptote is basically a vertical line, basically a invisible vertical line that never gets crossed or touched. A graph will get close to that vertical asymptote, will get very close to it, but never ever crossing or touching it. Okay? So that's what a vertical asymptote is. So, which means that on the vertical asymptote, whatever it is, the function is actually undefined at that location. But as it gets closer and closer to it, you can still find values for it. It's just that where the vertical asymptote actually is actually undefined. So I'm going to do a couple of examples here, and we're going to talk about, how to figure out where the vertical asymptotes are. Again, it's related to restrictions. Okay, so let's say, for example, that g of x is equal to x over x squared minus 4. Okay? So what we typically do, we'll say, well, my x squared minus 4 cannot equal to 0, right? All right. Well, I'm going to do it as equal to 0. There's two ways of solving this. One way is, like you already do now, is factor. X minus 2 x plus 2 is equal to 0. So I got x equals 2 and x equals negative 2. Okay? There is another way of solving this. So I'm going to show you guys that method as well. The other way of solving for this is saying that I'm going to try to get x by itself. So I'm going to have x squared is equal to 4. So I'm going to just rewrite this. So if I have x squared equal to 4, then I would have to take the square root of both sides. The biggest part that people miss is that when they physically take the square root of both sides, you have to have this plus or minus, okay? So that means I have x is going to equal to positive or negative 4. I'm sorry, 2. Try again. 2, because the square root of 4 is 2, all right? So, same answers, okay? What does this tell me? It tells me that my restrictions that x cannot equal to negative 2 and x cannot equal to 2. How does that affect my domain? So it can be anything it wants to be, but it can't be negative 2 or 2. So my domain is going to be from negative infinity to negative 2, union with negative 2 to 2, union with 2 to positive infinity. Okay? So, in this case, my vertical asymptote is x equals negative 2 and x equals 2. In other words, I have a vertical line of x equals 2 and x equals negative 2. So let me do this. Here we go. All right. So let's take a look at the next example. The next example I'm going to put down is what we already have, which is f of x is equal to x minus 2 over x squared minus 4. Okay, so I already would do exactly the same thing, right? We would do x squared minus 4 equals 0, right? So my restriction is still the same. My domain is still the same. So in other words, I can share this restriction with both. Okay? However, the vertical asymptote, a little bit different. So let's talk about that part. Well, yeah, let's talk about that part. Okay, so how is the vertical asymptote different from the g of x versus the f of x? So something to put into consideration here. That is, let me see here, I need to pick a color. You know what, let's do it in red. So I know that the f of x No, let's do it in blue. Purple? Yeah, let's do it in purple. So I got f of x is equal to x minus 2 over, so technically speaking, I would factor this, right? So let me, I would actually have, if I was to factor the denominator, I would actually have x minus 2 and x plus 2. So let me put this closer to the center. And since the numerator doesn't factor anymore, I put parentheses around it, right? But I want you to notice something. This is kind of a big deal here, okay? If you notice that my x minus 2 can cancel out. So we talked about before where the restriction is still the same. So therefore my domain is still the same. However, the asymptote changes. So let me do this really quick. I'm actually, you know what? I'm actually going to get rid of this. I'm going to move this part down here, okay? Just so that it kind of separates the two. So how does that affect it? Well, the vertical asymptote is still going to be where am I? Purple. No, yeah, purple. So my vertical asymptote, the part that doesn't cancel is still my vertical asymptote, meaning my x equals to negative 2 is still my vertical asymptote, okay? Actually, put this underneath so it really keeps it separated. However, question is, what happens with a piece that I have canceled or crossed out up there, right? Because it's still my restriction. It's still part of my domain, but what happens since it could cancel? Well, the x equals to 2 is now not a vertical asymptote, okay? So not a vertical asymptote. However, it is an open circle. Okay, so we have to remember that. Okay, so the vertical asymptote is still going to be, so we might as well change this to that color as well. Okay, just so you can see what's in purple and what's in blue, which crossed out. Okay, now notice that on the g of x, nothing would reduce because I only have an x, so it doesn't reduce the x minus 2 or x plus 2 in the denominator, so that's why that is pretty straightforward, going straight through, no big deal, okay? So, however, if anything was to cancel, then that's going to be your open circle. The part that doesn't cancel will be your vertical asymptote, okay? So, let's put it this way. Yeah, we should have enough room. If not cancel, or let's use a different word. If not simplified, no. I guess I should use cancel. Or crossed out. There we go. So we got that right there. Let me see. All right, so we got that in there. Okay, so you guys got to remember that. Notice that that is a vertical asymptote, and we might as well put that box right here as well, so you can see the two boxes. Okay, all right. I have a third example. And the third example is, what if h of x is equal to x minus 2 over x squared plus 4? Well, you would start with x squared plus 4 is equal to 0. You know, and the reason why I wanted to show you this method over here of taking the square root of both sides is because you can't just say it's not factorable, I'm done. And it's not always that something that's not factorable is always going to be this way, right? Because you always have the quadratic formula, right? Or completing the squares to also solve for this. The part that I want to show you is this. So let's say I need to solve for this. So I said, okay, x squared is equal to negative 4. Okay, so I got x squared is equal to negative 4. I have to take the square root of both sides, but that means I need that plus or minus. So that means x is going to equal to plus and minus, and this would be 2i. Well, this is not real, right? And since it's not real, then it means that I have no restrictions. That means my domain is going to be negative infinity to positive infinity. Since there's no restrictions, I have no vertical asymptote. Actually, you know what? Let me do it this way. No open circle. And no vertical There we go. All right. Okay. There's a reason why I did this way. Just so you guys know, I did have a plan, and here is the plan. Oops. Undo. And here's the reason why. Yeah, why not? Always. go. Okay, so there we go. All right. So you see why that's a shared restriction domain. However, the vertical asymptotes are different. All right. All right. There we go. So that is number 4. All right. So the question is, what's step number 5? Come on. Okay, so step number 5 is to find the horizontal asymptote. After we find the vertical, we gotta find the horizontal. Okay? Now, the horizontal asymptote is very different compared to the vertical asymptote, right? So the vertical asymptote is about the restriction and about the domain. However, the horizontal asymptote is a little bit different. All right? It's actually based on, so what you want to look at is the highest power on the top and bottom. So the highest power in the numerator and the highest power in the denominator is what you want to look for here. Okay? So let's say the highest power is on the top is a x to the nth power, and the highest power on the bottom is not a b x to the m. Okay, now the rest of it doesn't really matter. We're focused on the highest power. Okay, so while looking at that, we want to say, okay, I'm going to kind of go in not in order here in terms of what they have. So I'm going to do it this way. So first case, first possible case is this. I'm supposed to switch to a box. Let's try it again. Maybe it doesn't work around something. All right, so I'm going to say the first case, if n is greater than m, so I'm going to throw the example right in here. So 9x to the third over 3x squared plus 1. So if you notice, I have to the third power and to the second power. Those are my highest powers, right? What does that tell me? There is no horizontal okay? There is no horizontal asymptote, okay? So that's the first case. What's another case? So another case would be if it is less than m, right? So for example, if I had 9 to the x over 3x squared plus 1, right? Because then we can see that the power here and a power here I wonder if I should do this. Hold on. There we go. All right. Because this is actually known as 1 power, right? Okay. And I wanted to keep it in yellow because it's not supposed to be there. All right. So if that's the case, the horizontal that looks so weird. Can't get over it. Is y equals to 0. Okay? And then I have a third case. And you guys already guessed it, if n is equal to m, right? So for example, I have 9 x squared over 3x squared plus 1. So if I look at those powers, they're the same. Well, in that case, is the ratio of its coefficient. Okay? So in this case, y is equal to, their coefficient is 9 over 3. So that means the horizontal asymptote is y equals 3. Okay? So there's your three cases. If n is greater than m, none. So the power on top is, the largest power on top is larger than the largest power on the bottom, no horizontal asymptote. If the largest power on top is less than the largest power on the bottom, the horizontal asymptote is y equals 0. However, if the largest power on top is the same as the largest power on the bottom, then the horizontal asymptote would be the ratio of the coefficients. The coefficient of x squared here is 9. The coefficient of x squared on the bottom is 3. So 9 over 3, reduce that fraction, I have y equals 3. Okay? So that's how I determine the horizontal asymptote. Okay? Now, with that being said, because we've done the vertical asymptote, we talked about the horizontal asymptote, this is where I kind of want to do a sidetrack of talking about and reminding you about transformations. Okay, so transformations, if you guys remember, we had this equation, right, that says g of x is equal to a times f of b x minus c plus d. Okay, so I know this seems long. Seems like a long time ago. However, there's only two pieces that we're really going to focus on right now. And our focus is going to be on the C and the D. Let's call that green. There we go. Okay, so we're only going to focus on the C and the D. Okay, so let's say that f of x was equal to 1 over x. Then my g of x would be 1 over x minus c plus the d. In fact, I should include that plus sign in that. There we go. I'm not sure if I like that D. So there we go. All right. However, if my f of x is equal to 1 over x squared, right, then my g of x would be 1 over x minus c squared plus d. Right? Because the c is what's affecting the x, because it's inside that parentheses, where the d is outside, so that's affecting the y. Right? So, let me also put over here to remind you guys that positive c means to shift left C units. Negative C means to shift right C units. Positive D means to shift up D units. And negative D means to shift down D units. All right? I guess I should go. Okay? There you go. So, how do I want to do this? That's what we'll do. I'm going to take these and slide it over. And take a shish and slide it up. There we go. All right. So I just wanted to give you guys a reminder of transformations. All right. Now we can go to step 6. Oh, now it doesn't. Well, step 6 is to plot points. So that we can do 7, which is graph. Okay? So what do I mean by plotting points? Well, plotting points, it means that I have to use a chart. I want to choose X values around the vertical asymptotes. Okay, so if I was to do f of x is equal to x minus 2 over x squared minus 4. Okay, so I'm going to kind of do it through Desmos. So what I'm going to do right now is I'm going to insert what it looks like. And it looks something like this. All right. Okay. I want to bring this over. I want to bring it over here. But I want to shrink it just a little bit. Let me see. Oh, I don't need to shrink it a little bit. Yeah. Yep. Okay. So this is what f of x equals x minus 2 divided by x squared minus 4 looks like. So it showed me that I have a vertical asymptote at x equals negative 2. Right? I have an open circle at x equals to 2. And I have a horizontal asymptote, which was, ooh, did I not do that part? Ooh, I did not. So for our example, sorry guys, for our example, I have x minus, I had f of x is equal to x minus 2 over x squared minus 4. So what is the top power? The top power is a 1, and the bottom power is a 2, right? So that means the n is less than m, right? Which means what? That my horizontal asymptote is y equals 0. Okay? Whew. Now that we got that done, so over here, I have my horizontal asymptote, which is y equals 0, which is also the x-axis. Okay? All right, so the blue line goes, so after those red lines, in order to get the rest of this, I want to plot points. I already had 2 points, right? If I come all the way up here, I had 0, 1/2, and 2 zeros. So if I come down here, zero, 1/2. What color was that? 0, 1/2 was red. Of course it would be red. All right. So 0, 1/2 is my y-intercept. And it says my x-intercept is 2, 0. Well, the problem is that it actually isn't 2, 0. Because, oh, that's why. This would have to get rejected. Because based on my restriction, x cannot equal to 2. So essentially, I would have to reject that. Okay? So now I gotta come back here and going, okay, but when x is equal to 2 is actually undefined, right? So therefore, there's no such thing. All right? Now, what do I mean by using a chart? So I also did that as well. So let me plot one right here. I'm going to start with, where's the one I want? Okay, that's the one I want. Okay, really big chart. Okay, so I want this right over here, okay? I'm going to give it draw, give me a box. I'm going to draw still. Let's see. It does. Perfect. Okay. Okay, so what's this orange box? So if you notice, my x went from -4 to -3. So if you notice this, let me go ahead and plot some of these points here. -4, -1/2. And then -3, 1, -1. 2 3/4. 2 1/2 is 2, right? And then 2 1/4, right? And so on and so forth. So if you notice, what am I doing? I'm actually having my x values going towards that -2, okay? So the way you will see this notation is actually going to look something like this. Ready? It's going to be as x approaches a from the negative side. Okay, so that's what that actually means. Okay, so in other words, as x approaches the vertical asymptote from the left or the negative side. Okay, so let me see here. Let's write this down. So this means So as x approaches the vertical asymptote from the negative side, which means from the left. Okay, so that's what that means. All right, so that's where I'm going. So as it comes from the negative side, where is it going? If you notice that it went from -1/2 to -1, right? Look at all my y values. It's going to -4, right? So it's going further. My y value keeps on going further and further down. In other words, towards -infinity. Okay? However, once it gets to -2, it's undefined. So it can get really, really close, but it's never going to actually cross or touch it. All right? So we got to do the same thing on this side. So we're going to go from now the right side or the positive side to get to -2. So I want to go ahead and put in another file right here. So I'm going from is that the one I want? Oh, yeah, there it is. Still really big. Whoa. Need a little more space here. Because I want this to be over here. I'm going to call that bleu. There we go. All right. So what's this blue one telling me? This blue one is telling me as x approaches the vertical asymptote from the positive side. So let's plot this. 0, 1/2, already plotted, right? -1, 1. -1.5 to 2, right? I don't even have a 3, but it goes all the way up to 4, and so on and so forth. So this is going from this end, right? Right? So in other words, I'm going, so let me write this down. So this means that I am as x approaches the vertical asymptote from the positive side, which means from the right. Okay? So that's what that means. Awesome. So the last two things we need to do is this. put that one in first. Now what we want to do, let's make this purple. So if you notice what this is showing is what? 10 to 100 to 990, right? The X value is. So in other words, we're going in this direction here. All right, so what is this notation? This is saying as X approaches positive infinity, okay? And that doesn't really need much explaining, right? As X approaches positive infinity, and then of course we need the other one as well. Which is really stinking big. And let's make that one green. All right, so I want this whole thing to stay right there. Let's leave it right there. Okay, so if you notice these numbers going -10, -100, -1000, if you notice what's happening is the Y value is getting closer and closer to 0, but it doesn't touch 0, right? All right, so this right here, the notation for this would be as X approaches negative infinity, okay? So really, it's the blue and the orange that you need the explanation to. Otherwise, everything else seems right, all right? So hopefully that helps. If you have any questions, let me know. So again, that is the graph. So we would go ahead and put in the vertical asymptote, the horizontal asymptotes, the open circles if they exist, all right? And then we want to kind of make some charts and plot some of those points so it shows us which direction those go, all right? If you have any questions, let me know. I'll talk to you later. See ya.